Hey there. Ready to dive into something both fascinating and relevant to, well, pretty much everything.
Sounds intriguing. Tell me more.
We're talking about p-values. You know those tiny numbers that are always in the news? Like, study shows eating broccoli makes you a morning person.
Oh, yeah, I've definitely seen those headlines.
So we're going to unpack what p-values really mean, and trust me, you'll look at research very differently afterward.
I'm ready to have my mind blown.
So you sent over some really thought-provoking excerpts on this, and one of the things that jumped out is how often p-values are misunderstood. It's easy to think they offer some kind of absolute proof. But what if I told you it was more about compatibility? Almost like seeing if a puzzle piece fits, even if we're not sure we've got the whole picture yet.
Okay, I'm intrigued. How do we even start to unpack that?
Well, one of the first things we need to wrap our heads around is this idea of conditional versus unconditional interpretations of p-values.
Okay, so right off the bat, we're already getting into the weeds a bit.
Right. It sounds complicated, but it's actually not. Let's think about it like this. Imagine you're baking a cake.
Okay, I love where this is going.
So the recipe is like our scientific model.
Okay, got it. The recipe equals the model. Go on.
The conditional view of p-values assumes we have the perfect ingredients, the oven's at the exact right temperature, and we followed every instruction flawlessly.
So basically a perfect world scenario.
Exactly. And if those conditions are met, then the cake should turn out great.
Makes sense.
That's what a p-value often gets mistaken for. A guarantee.
Yeah.
Based on a perfect scenario.
Ah, but life's not a perfectly measured recipe, is it?
Exactly. And that's where the unconditional view comes in. It's like saying, hold on, what if the oven runs hot or we accidentally use baking soda instead of powder?
Which, let's be honest, happens to the best of us.
Right. The cake might still be edible, but it won't be quite what we expected.
And it might not even be edible. So are you saying that's how we should be viewing research results too, with a grain of salt, so to speak?
Exactly. The unconditional view encourages us to question those underlying assumptions.
Because things aren't always as they seem.
That's so important because, as one of the excerpts you sent pointed out, emphasizing unconditional interpretations helps avoid overconfident and misleading inferences.
Which is what we want to avoid at all costs, right?
Right. Because it's like thinking we've solved the puzzle just because a few pieces seem to fit, without considering if we forced them into the wrong places.
Right. And then the whole picture is off. I see what you mean.
Okay, so we've got this cake, and it might be a bit wonky because, well, sometimes ovens have a mind of their own. But here's where things click for me in a big way. What if instead of saying there's a 95% probability this cake is delicious, we ask, how compatible is this slightly lopsided, maybe a tad overbaked cake with the idea of delicious?
That's a fantastic way to frame it. You're hitting on a crucial point about how we often misinterpret confidence intervals.
Right. It's like those confidence intervals we see in studies. Maybe we should be calling them compatibility intervals instead.
I love that because it moves us away from this idea of absolute probability towards something more nuanced, more realistic.
So how does this all link back to p-values? Is there like a p-value for my potentially disastrous cake?
Well, one of your excerpts puts it perfectly. The p-value is not an absolute measure of evidence. It is a continuous measure of the compatibility of the observed data with the model used to compute it.
Okay, unpack that for me. We've got data, my cake, we've got a model, the recipe.
Exactly. So a low p-value for your cake wouldn't mean it's objectively delicious, just that the outcome, your cake in all its imperfect glory, is pretty compatible with the recipe you used, even to the oven threw in some curveballs.
Which brings us back to those unconditional interpretations we talked about earlier. It's not just about whether the data could fit the model, but whether the model itself is even the right one to be using, given all those real-world variables.
Precisely. And that's why blindly chasing statistically significant p-values without considering the bigger picture can be so misleading.
Which leads us to the big question. How does this apply to me in everyday life? Beyond just questionable cakes, that is. It's like when you see those headlines like, study proves coffee makes you a millionaire.
Right.
But then you find out the p-value, while technically significant, doesn't consider all the other factors at play, like maybe millionaires tend to drink more coffee just because they can afford to.
Exactly. Or those health claims you see everywhere. This one weird spice cures everything. Just because a study shows a correlation and a seemingly impressive p-value doesn't mean you should start stockpiling turmeric.
Right. So we've got to be careful not to just blindly trust any headline with a p-value attached to it. But does that mean we need to become statisticians overnight to understand anything?
Not at all. What's empowering is that even a basic understanding of these concepts can make you a much more critical consumer of information. And the good news is there are tools that can help us go even deeper.
Oh,
Like what? Well, your excerpts mention things like equivalence tests and SLALUs.
which, let's be honest, sound a bit intimidating.
They do. But they're really just different ways of looking at statistical evidence. Instead of just asking, is there a difference? These tools help us ask, is the difference big enough to matter?
So instead of just looking for any old difference, we're looking for a meaningful difference.
Precisely. And that's a game changer, especially in fields like medicine or finance, where even small effects can have big consequences.
Going through all this has been like getting a crash course in statistical literacy. I feel like I've got a whole new set of lenses to look at the world with.
That's the beauty of it. It's not just about memorizing definitions. It's about developing a critical mindset. And now, equipped with this knowledge about p-values and their limitations, you're well equipped to see through the hype and understand the nuances of the data-driven world around you.
So the next time you come across a study or a news article that throws around p-values, remember what we've talked about today. Don't just take those numbers at face value. Ask questions. Consider the assumptions. Think about the bigger picture. Because a true understanding of p-values isn't just about being statistically savvy, it's about being an informed and empowered citizen in an increasingly complex world. And that's a journey worth taking one p-value at a time.